Good evening, everyone. This video goes out to Shane St Pierre because I was talking with him this last weekend gone about comparing like latitude and longitude, sort of, on the ground, on maps, all that sort of stuff. Now, of course, do we trust Google Maps for the latitude and longitude? I don't really know, but I mean, it's really easy tool to use to be able to find that sort of stuff. Anyway, so my quest was to go out there and see if I can find some sort of east to west road that was at least like 6.9 miles, or maybe even a fraction of that, whatever the case, something not too long. And I had a bit of a quick look at the end of the weekend, and I looked. I've known Melbourne for years, that it's always had a bit of a grid-like road system. There's only one issue though. The grid road system has been on like an angle of about 10 degrees or maybe 12 degrees or something like that forever. As you can see, all of these roads are all on this exact same angle. It even carries over to Truganina and Footscray and all the way up to like Reservoir. It's all the same angle. I mean, even if you look out, we got Pakenham, similar angles. You go out to Warragul, similar angles. And if you go down Geelong, look at that, a whole different city, same angle. They've correlated that angle with this one over here. So it was like, interesting. Tricky. So I thought, well, okay, do I find some sort of individual road? And I kept panning around. And mind you, I know for a fact that some of these northern ones up here near Echuca and Moama, they have a really good east to west position. But look, that's going to take me 4 hours to drive to. So if I go up to Bendigo, or if I go up to Moama or something like that, sure, I might go out there and test those ones too. But at the point in time, I was looking around Melbourne, looking for what I could. So while looking, I found two zones which seem to have an east-west, north-south type road setup, and they're both down in this southern region. So once you push past down Lake Warren, some of them in Tyab, you get quite a few grids here, as you can see here. Graydon's, Hodgins, what's this one here? Hunts Road, Myers, bit in Dramana, and even a little bit of Stanley's is good east to west pathways, and even I think this one here. Let's have a bit of a look. Coollart Road's almost dead north south over here. And the other zone which I found to have very good similarities was the Phillip Island region. So we got Back Beach Road, which is a nice long road that's east to west. Ventnor Beach Road is east to west, and most of the roads in Cowes are all east to west too. So I thought, okay, what can I do? So I thought I might pop down to go to Tyab area, and I was tossing up, maybe booking a hotel down here sometime, maybe 2 weeks away or something like that, to test out this road. But for the moment, this one can be accessed a lot quicker. It doesn't, it takes, I don't know, it takes like an hour or less or something like that to go out there and get to. So, but this one's going to take like 3 hours to get to. So, sorry, not 3 hours, but like 2 hours. So this one was a lot easier to get to. You basically hit the freeway and you're in this zone in no worries. So I thought, okay, what should I do? Should I go down this one here, back down Stump Gullies, along Myers, and back up? And I thought, well, that's majority north-south. It's not necessarily majority east and west, because it's the east and west which is the point of contention here. Because we can always say that north-south, we should expect it to be 69 miles every single degree of latitude, right? It's the longitude, which is the part which is the confusing part. So I set myself up. I drove down here, parked here at Bunnings, and set myself up to go and get myself ready for a drive. And I decided to do a loop and reset my odometer on my car at each corner. So I set it up here, and I drove from the corner of Graydon's and the corner of Frankston Flinders Road. So I set myself up there. I zeroed it out, and I drove all the way past Bose and past Coolar, and then I shot past Stumpy Gully because I basically wanted to make sure that I crossed at that certain point, and so I took note of where the distance of my odometer at that point, keeping in mind that the odometer is in kilometers and 1 decimal place, which mainly means you got a variation of 100 meters, which is not accurate, but we're driving long distances here, so we can probably say that that's okay. And I headed down to Hodgins. I initially looked at what Hunts was, and Hunts is a dirt road, so I thought no. So I went down Hodgins, and so I went from Stumpy Gully down Hodgins, and then I went through this roundabout back to here, and then back to here. And so I got the distance of this one here, this pathway here, and I got the distance of this pathway here, and the distance of this one, and the distance of this one. So the first leg was about 4.9 k's on the northern path, not that one yet. Okay, so this path here, pathway number 1, that was 4.9 kilometers. All right, that was leg number 1. Leg number 2, I got 0.6. Now I'm a little bit skeptical about this one. I think that it was probably just about to tick over to the 0.7, because it kind of was on 1.6 for a little while, and when I've actually measured it, it's come out to more than 0.6. So, and then I went along Hodgins all the way back to here, and so leg number 3, bang, 4.9 again, so very, very consistent. And then the last leg back up to the top was 1.6 again. So I know for a fact that it seems to be coming out a bit of a square or rectangle. And both long distances and both short distances are very, very, very much the same. So Graydon's 4.9, this one 1.6 or greater, this one 4.9, and this is 1.6 or greater. So with those log distances in mind from my physical driving observation, and I knew that I was going up and down hills, distances could be out, who knows, I now have something I can compare. Now, one thing I did go and check, so I went and put a pin on here, and you can do measure distance, and you can also get, mind you, I'll just clear that. So when you right click here, you can get, it's negative 38 degree 0.284, and it's 145 degrees east, right? So you can do measure distance from here, and I brought it all the way along to here, and I got distance to here. Yes, I know, puss, I know. So I got 4.92. That's fairly consistent with my god cat. Get out of here. 4.92, that's pretty consistent with what my odometer was saying. So I'll clear that. Now, when I restart here and I go measure distance, and I go down to Hodgins Road roundabout, and I get distance to here, it says 1.72. Now, I think one of the things that I had a problem with was the fact that I had to press the button, and I think I might have been like about 20 meters or something like that actually into the actual road before I had to do that, because of stuffing around trying to change gears and obviously get myself fired back up again. And of course Hodgins all the way over to here, distance to here 4.92, as you can see once again. And then if I measure distance all the way back up to the top again, you'll notice that, yeah, it's about 1.7 meters again. So 1.7 kilometers. So they are pretty close to what I reported on the ground. And yeah, it kind of proves, for me, that Google Maps seems to be pretty close to what I've measured on the ground. Now, let's take note of these things. 38.28 degrees south, 145 east. The other point over here is 38.29999 and 145.18. Stumpy Gully over here. So I got 38.3. So I noticed that the other one was 38.929999. We've got 145 east, 0.27, 127. And I've got 38.28 and 145.27. So that's roughly the numbers. Now, what I've already done is I've already transferred this onto a model, so that it makes it easier. So the measurement that I was getting for both Gradens and Hodgins was 4.9. Stumpy Gully, when I did the Google Maps check, it said that it looked like I was probably averaging about 1.69, so I was probably ready to tick over to the 1.7. And of course, this is those angles. So south 38 degrees 28, and south 38 degrees 300. And south 38 degrees 299, south 38 284. Cat, go away. East 145 degrees, right? East 145 degrees. East 145 degrees 2.27. East 145 183. So this is all consistent data, right? I've placed it all. This is roughly what it should look like. Now, of course, when I do a quick Google, 1 degree of latitude is roughly 110 kilometers long in metric system, and 1 degree of longitude cannot be defined as it varies. It varies between 110 all the way to 0. And so I've written here, therefore, a flat Earth must be 110 kilometers times 180, right? North pole to south ring should be 19,800 kilometers in length. Google says the North Pole to the South Pole is 20,015 kilometers long. That makes each latitude about 111 kilometers. But for this instance, because that was the first thing they're quoting me, and I'm just going to go with what they say I possibly can use, I'm going to go with the 19,800 for this exercise, right? So this circle here is the 19,800. So when you measure from here to here, what you'll get, I don't know if you can see it, but it says 19,800. So I've got a much larger scale here, just because it's just a little bit easier to be able to sort of tweak with the numbers, right? So 19,800. This is North Pole. This is the Southern Ring. This is flat Earth, right? So what I've done here is I've got Graydon's Road, which is the top road, the more northern road, and so the summary I've got basically here is I've got it's south 38 degrees 284 plus 90 is 128 degrees 0.284 from the North Pole, and as you can see, I've times that by 110. The radius from the center should be 14,111.24 kilometers, and Hodgins, doing that same maths, if you could look at the screen, you can just read it. It should be 14,112.89 kilometers from the center. So that's the distance this upper and lower road is. That's basically how far away they are. Now, I did these two angles off here because one of them was east 145.127 and east 145.183. So one represents the left-hand road, which I think is Stumpy Gully, and this one is like Frankston Flinders. Now for flat Earth, this is flat Earth, right? That's flat Earth. The distance that the long road, according to flat Earth, should be is 13.79 kilometers. Now I got 4.9 kilometers, and this says 13.79 kilometers long, right? Now the vertical distance that I got was 1.6. Google Maps says 1.69 to 1.7, and so on the flat Earth, this calculation comes to 1.65. So we can just sort of say, well, it's too vague for us to understand, but there's no doubt that 13.79 kilometers is not how far I drove when I drove from Frankston Flinders all the way to Stumpy Gully Road. I drove 4.9, not 13.79. So moving on from the flat Earth, right? This is the globe Earth model, right? So we've got the North Pole up here, the South Pole up here, and this is the equator, this horizontal one here, and these two angles over here shoot down to where I was in Australia, in the southern hemisphere, right? So imagine Australia being here, you know, Sydney over here, Queensland over there, so on and so forth, right? 38 degrees 284, 38 degrees 299, right? So the orange one is the top one, and this is the bottom road. So this one's like this one. What's the top one again? Graydon's is top, Hodgins is bottom. All right. So Graydon's is the one up top, the orange, and Hodgins is one there. And so basically, what I need is this loop. These two lines here basically represent like if you tightened a belt around the bottom of the actual globe, that's their radius from the center pole. That's their distance. So what this one gives us is it gives us the length north to south, and for this one it's come out as 1.669 kilometers. Now once again, it's kind of close to the other one. It's hard to really know what is the ultimate answer, because one was 1.65 and the other one was 1.669. It's too close to call, right? It's just not worth it. But when you correlate these two radius strike lines down to this ring. Now this ring is not the radius of the globe at all. This is the radius of my two belts. So this is where you tighten the belt around the bottom of the globe. This two circles down here represents the two belts around the bottom of the globe. And so as you can see here, the orange touches the orange, the grey touches the grey, right? And I've copied this exact same 145 degree east over to here and put it out here. So you can see 145.27, 145.183, right? And the distance, and I can show you the distance down here just in case anyone is confused. So I've got that. So I'll zoom in on the part down the bottom, as you can see. So I've got 4.893. And I don't think I can measure the vertical one here because I don't think it's permitted, because I'm basically measuring the two belts. It's not how we measure north to south. So I can't measure this north to south part because it just says 1 kilometer, which is wrong. But this is from the belt width. It's 4.893. Let me just double check that again. Yeah, 4.893. Now 4.893 is a lot more similar to the 4.9 kilometers that I drove back here, right? 4.9 kilometers. Okay, so in this model, in this test, if I can verify that these coordinates are correct for those road junctions, then I can happily say that the 1.69 or 1.6 measurement is negligible in comparison from flat Earth predictions to globe Earth predictions, but the length of Hodgins and Gradens is is significantly different. So for flat Earth got 13.79 kilometers long, whereas globe Earth got 4.89 kilometers long. So globe Earth wins this challenge if those coordinates can be trusted. And anyone can go back and just test my coordinates. So yeah, that's our experiment for this one. I do have a little bit of footage of this, but I don't think I want to show it for the simple reason that I'd rather you look at a photo personally. There are legal reasons why I don't think I want to show you. I'll leave it at that. You can make up your mind as to what that means. So yeah, that's what this thing is here. So let's see. If anyone has any more questions, I might go and do the Phillip Island one and go, because I wouldn't mind doing this one here from, well, I can almost start from this corner. It doesn't really matter. Because this one here in Phillip Island, if I measure the distance, if I go all the way along till Smith Beach Road junction right here, and distance to here, I got 8.46 kilometers long. That's almost the 11 kilometers it requires to be 0.1 of a latitude or longitude distance. So this one would be a very, very cool test. A very cool test, because that looks like one of the longest pathways I've got. So 8.46. Let me just double check. Let me just check what Stanley's is. Let me just check that, because Stanley's is a pretty big one too. Measure distance. Let's go all the way into Middlebourne narrowing distance here. 6.9. Yeah. I don't think it's quite as long. No, it's not as long. So the one over Phillip Island is gold, no doubt about it. So if I make it over there, if I get requests to go and do it, that would be pretty cool. This one here would be interesting too, but I think that some of the stuff through Merrick's is very bouncy. Let's see what the distance is to here. Yes, I know, kitty cat. 7.8. 7.8 is not bad. 7.8 is not bad. But either way, at this point in time, Globe Earth has won this test, hands down. 4.9k versus what, 13.79. Flat Earth has some explaining to do. So there you go. All done. Quick test. Thanks for watching.